Okay, so now we're going to study about the extraction techniques in Pandas, which gives us the power to extract subset information from a data frame, which we can use to further elaborate and study them, to explore more about them, to extract more insights from them. So let's look into it. So the first thing we're going to study is extracting specific columns. So the specific columns in a dataset are actually the features, and in order to study these features collectively or individually, we need to extract them and into a different data frame. So whenever we use the extraction feature and extract specific columns, they are actually copied into a separate data frame, which we can use to further elaborate our study and explore more findings in them, especially when we're in the EDA phase, exploratory data analysis, and when we're looking into the more elaborate concepts and where we can actually come up with new ideas. So this is another technique we're going to study. So coming to the syntax of this is similar to what we have seen before in reading a particular column. So what we do is we copy that particular column to another data frame, which we obviously has a different name of it, and then we're going to visualize those techniques. So if you want to select one particular column, we're going to use single brackets, square brackets for that, and then we're going to copy it into another data frame. And if you want to select a subset of columns, then we need to use double square brackets. And you need to be careful whenever you're writing this down, because this different syntax can make a greater difference. So be sure to note it down. So this technique will also be used in feature engineering whenever we are studying and engineering new features. So Pandas actually provides us with these tools, and they're very important to learn now. As I said before, that it's important to learn about what, and later on we're going to focus on why. Moving on, let's look into another concept which has to deal with the rows. Selecting rows is another useful property which Pandas provides us, and this is similar most if you have any programming background, if you have studied SQL. Selecting rows from a particular data set or data frame is that when you're targeting specific information, and in order to extract that, basically you're targeting rows. So in order to extract that information, you should learn how to select these rows. Like I said before, there are different indexing techniques of 2D information of data. So tabular data, we have rows and columns, and in order to extract both of them, in order to learn from them, in order to visualize them, it's important to learn how we can extract them at first. So selecting these rows and columns comes at the first most important priority for any data scientist who is dealing with data. So we have studied indexing techniques and we have studied slicing techniques in NumPy. It is quite similar to that concept. The only difference we're going to see here is the difference in syntax. We're going to use the iloc, which is used specifically for extracting rows, and this tells us, instructs data frame that we need to extract the rows, and then we're going to give it the starting index and the ending index for those particular rows. So in this example, we have selected the 9th index, the 9th row, and we're going to the 14th row. So it will select the 9 till 13 inclusive, and it will exclude the 14th row, just like the indexing techniques in NumPy. So it's quite simple. It is just like extracting a particular chunk of rows from a larger data frame. So the question you should ask here, why is any of that important? This doesn't make any sense without extracting just information, without giving it any further information of what exactly you want to extract. So let's look into that. So let's suppose you want to extract, or you can say select rows with rooms that are greater than 100. So now we're going to introduce a condition in the selection process. This is what we call the conditional statements. The conditional statements specifically tells us that in this particular example, we have selected the rooms, we have selected that particular column, and we're introducing a condition that the values in these rooms need to be greater than 100. After that, we're just going to copy that value. So you need to make sure that we have, before indexing, there is another square bracket that ensures, which basically is a syntax condition, that you need to instruct Pandas that it is all inclusive within this particular data frame, so that you don't extract the series instead of a data frame. If you do not use the outermost square bracket, then it will give you the data structure of series and not the data frame. So please note that. Now this particular statement will give us information of all the rooms that are greater than 100. Now you see and understand the essence of why this particular function is important and why we need to learn it. Okay, so we have seen extracting rows and columns independently, but let's say you have to extract both of them in one particular function, and you have to extract information depending on some selected columns and selected rows. So how do we do that? Obviously, we're just going to add more conditions, but let's look into the syntax. So the indexing concept is further extended, and we're going to see that it's important to remember that we're still dealing with 2D data frames, and all these values are tabular data. This is the 2D matrix if you want to conceptualize the whole concept. It is important to remember. So the first index tells us that we're extracting the rows, and the second index tells us that we're extracting columns. So the columns also have an indexing property, so as the rows. So we need to use those indexing properties and to use that to extract information from the specific columns and rows. So now we have selected 9 to 13 rows and 3 and 5 number of columns. So in this way we have a data frame that only contains information of these two particular columns and these rows. Okay, so let's look at this particular example. So you now understand we're building up concepts and it's getting more and more structured. You're beginning to get a sense that how Pandas makes it easy to extract insights and enables us to explore the data. So let's look at this example. In this example, we're going to select rooms that are greater than 100 along with the median house value. Okay, so we are going to select only those rooms which have greater than 100 value, and we're going to extract the median house value of that information. So now we have used slightly different syntax in this. Rather than ilog, we are using lock, and this is where we are going to particularly extract median house value. And as you can see, this is not a data frame that has any column value, but we have this in a series format. So this is a series data structure and not a data frame, because we have only extracted one particular column and all the columns in a data frame are series. So let's recall what we have learned so far. When selecting subsets of data, square brackets are used. That is a part of syntax, and that is very important to remember. Inside these brackets, you can use single column or row label. Inside these brackets, you can use a single column or row label, a list of column or row labels, or slice of labels, a conditional expression, or a column. So like before, we have seen different ways to use these square brackets to select particular subsets of columns or rows. And depending on those subsets, we can also add conditional statements by using comparison operators so that we can further extract selective information to explore our dataset. Moving on, we have also seen that selecting specific rows and columns using the lock function when we were using the rows and column names. So the difference between the lock and the ilog function in Pandas is that in the lock function, when we are accessing the particular rows and columns using their names, and in the ilog function, we're using their information by indexing operation and not the names operation. So this is the difference between the both of their functionalities, and if you want to remember them, this is the best way you can remember them. Lastly, we have seen that we can also assign new values to the selection based on lock and ilog. So when we have selected those rows or columns, we can also assign new values to them, especially in the renaming function, or if you want to introduce a new column in the feature engineering process, and so on and so forth. Okay, so let's talk about aggregating statistics. This is so far the most valuable operation Pandas can provide us, because in this way we can process the information in the data frame whenever we want to calculate mean, median, mode, and any other statistical information provided in the dataset of a particular column, and we will see how we can do that. So when we're doing the aggregating statistics, we're mostly selecting a particular column and we're extracting information based on that column. So the output is a constant value, and it is not a data frame, it is not a series object, it is a constant value which provides us with useful insights about that particular column, or you can say in a more machine learning terminology that it is a feature that we can study it in a much better way using these statistical insights. So let's talk about calculating mean and median first. So we will select a particular column using the indexing technique we have seen, and then we will call the function of mean and median. And we can also do that on a single column and collectively on two columns as well. And that will give us information about their means and medians along with their data types. So it's a quite useful operation, especially when we want to get a more statistical view of our dataset, and so that we can use that information to select different machine learning algorithms, and we can also decide how we need to process our dataset based on these information. So let's see how to quickly get a quantitative info about the dataset. For that, Pandas gives us a quite comprehensive function which is called the describe function. This describe operation provides information about count, mean, standard deviation, upper quartile, lower quartile, median, maximum, minimum values of all the columns in a data frame. So a data frame of all consisting of all columns or features, you can quickly get their information using this simple operation. So this is so far the most wonderful tool, wonderful operation Pandas has provided us. And if you want to quickly do a quantitative check on the data, if you want to get a quantitative feel about the data set, this function is popularly used. So we can also use the describe function on selected columns as well. So it's quite smart. If you don't want to get the information of the entire data set, you want to focus your study on particular columns, you can select those columns and you can call the describe function on them, and then you can take up that information. So let's discuss these values we have provided. As you can see, there is no median provided in this example. The reason for that is we have been provided with the 50% value. The 50% is actually the middle value of the dataset, which tells us that this is the median. So don't get confused if you cannot find the median value. The 50% is the middle value of the data. It is considered to be the median. And the 25% and 75% are the lower and upper quartiles. The count information in this example tells us about the total values there are in that feature. So what if you want to calculate the frequency of individual value, like we saw in the histogram? We wanted to extract information of the frequency of each value. For that, we will use the value counts operation. We will call a particular column and then we will call the value counts operation, and that will give us the count of each particular value, and then we can use that to further draw a histogram or further get us about information about which, if the data is sparse, or which value is most common or which value is not. So if there is a value that has a very high frequency and that is going to affect your further processing, so it's important to find that information beforehand before you start processing the dataset. So let's recall what we have studied. We have seen the mean, median, mode functionality. The describe function is a beautiful operation for that. Then we have seen calculate frequency of each individual value. Then we have seen value counts, and these are quite comprehensive methods. You can do quick quantitative analysis on your dataset using these values. Okay, so let's talk about another functionality, another concept in which we will discuss merging two different data frames into a final data frame. So the merge operation in Pandas has this syntax, and this is how we write it down. The result is the left data frame and the devices is the right data frame, and this is the syntax. And this way we are going to write down the format, and this is the way we write down if you're merging two data frames. So the first data frame will be the left one, the second one will be the right one, and the left on is basically the column name on which we are performing the merge operation. So whenever we are performing the merge operation, they are on particular columns. The two data frames must have one common column, so that on which it will be based, on which the merge operation will be based. So if the two data frames do not have a common column, the merge operation will not function. So it's very important, and actually it is the basis of the merge operation. Or if anyone has if you have a SQL background, you will see that we have studied join operations there, and joining two different tables is based on a primary and a foreign key, and a foreign key is the key which exists in both the tables. So imagine this, that it is a particular feature which is common in both the data frames, and on that we can merge two data frames. So we will specify which is the left column name and the right column name on which we will perform the merge operation, and then we will specify which type of merge operation we want to perform. We have the left, right, inner and outer types of merge operations, and we will see how we can understand and learn from them and how they are different from one another. So this is an example of a data frame in which we have the user usage data of an Android device. There is the outgoing minutes per month and outgoing SMS per month. We have the monthly MBs of data usage and the user ID, which is in this particular example the primary key, and which specifies the exclusiveness of each user, and that is how we will uniquely identify them based on their user ID. Secondly, we have another data frame which gives us the information of the device, their brand, the marketing name, the device ID or the model number, and the information like this which gives us the particular, you can say, the information about a device. So we have the user usage device and the devices itself. So we need to merge these two data frames into one data frame. So let's merge them using this syntax we have learned. So we're going to select user ID, platform and device from the user device, and we're going to select the user usage on the left data frame and the right data frame, and they will be merged on the user ID. So the common column in these two data frames is the user ID. So that's why we're merging on that. Now you can see that there are certain columns which have a repetitive value now, because they were not the, you can say, the primary key, the primary column which uniquely identified them. So they have repetitive value, but even though these columns have repetitive value, the rows are still unique, and they are unique based on that user ID. So now we understand the importance of having a common column that uniquely identifies each row. Sometimes the situation is not ideal enough in a particular dataset that you do not have unique column names, or you can say a unique feature which uniquely differentiates between all the rows. So in that particular example, in that particular dataset, you have to introduce a unique key, or maybe use the index values as the unique, say, column on which you have to merge. So since the index values are unique, each one is exclusive of the other. So that is a good option if you do not have a primary key or primary column in a data frame. So let's look at the syntax we have used. So on the left side we have the user usage data frame, on the right we have the user device. So we, apart from that, we only want to merge 3 columns from the user device. We do not need the other information. We are only concerned about the platform and the device. So that's why we select these columns and merge them along with the user usage data frame. So the merge operation, the intuition behind it and the reason behind it is that we need to learn about distributed databases, and we need to study them collectively so that we can understand the relationship, and we can study more features at the same time along with both of the data frames. So this is a wonderful process through which you can learn about how you need to study different distributed information across different data frames and merge them to study them collectively.